Willkommen, bienvenue, and welcome back to the Modding of Isaac with Lyte. And today we're going to be covering functions and scope. I know some of you are brand new to coding, and so you just need to know what programming is like and what the rules are. And for those of you that are familiar with coding, there are a few little quirks to the way Lua works that might interest you. It might be a little slow to get there, so I'll tell you right off the bat that tables are sent by reference, other variables are sent by value. So pass by reference for tables, pass by value for non-tables. Now, all you ordinary folk who just want to learn how to program, we're going to cover functions and scopes. So in Isaac itself, all we're really going to do is we're going to sit here and we're going to see the final result of our program. Up in the upper left, you see final result 1. And if we head over to our program, all we're doing is printing out the contents of the variable A. That's all we're doing. That's all we're going to do this entire episode, is print out the contents of A. But we're going to do a few things to A along the way. So the fundamentals of programming are you start at the top, you go to the bottom. Occasionally, things redirect you, but you're always going downhill. So it starts up here, works its way down to setting A to 1, then it does this stuff. And every frame it'll do this and it'll print A into the game. So if we were to go A equals 2 and save it, head back over into Isaac and rerun our mod. So Lua mod A. My mod is named A. Our new result is 2 because we set A to 2. I know, super simple. You totally knew that was coming. There's no problem there. What happens if we put a second equal sign? We hit save, we come back in, and we run it again, and it freaks out! Well, because we told it to do something ridiculous. A double equals 2 is an expression. It doesn't work with... Oh, right. Should keep in mind that we need to switch back to Isaac. So, again, Lua mod equals A. Lua mod A freaks out. It doesn't show anything. That's no good. Because we told it to do something that's no good. Because 2 equal signs checks for equality. 1 is assignment. So A equals 2 may or may not work. So let's give it a save. Let's give it a run. And it evaluates to false. Oh, I'm gonna be real bad at this episode, aren't I? So the result is false. Do you know why the result is false? So if we look at our code, we take A and check if it's equal to 2. And then we assign it to A. And then we print A. So since A is not equal to 2, we set A to false. Okay? I'm just showing you basic assignment sort of things. So what if we want to do something with a function? Well, we want a local function, because we don't want it wandering all over the place. We'll cover scope later. It's what local does. So we have a local function called do something. And then in these parentheses, we give the function something. We pass something to it. Run a little relay race, we hand it off, I don't know, B. And then how about we just take this and move it in here. And then we return it. We pass it back to where we got it from, which means down here, A equals do something of, let's do 2, and replace this 2 with a B. I know I just did a lot of things, but it'll be fine. So what we do is we have A equals 1. We define a function, and we set a equal to the result of doing something with the number 2. This number 2 gets shoved into b. And then we check, does a equal b? Take that value and return it back out into a. This is the basic workflow of any function you're ever going to come across. In the API, all sorts of functions hand things back to you. And so you have a thing that is now equal to something else. For example, when you need a vector, and you say vector, open parentheses, a number and then a number, it hands you back a vector object. When you say color and those 7 parameters, it hands you back a color. So even if you don't do blah equals vector or blah equals color, that's what it's doing. You hand it some things and it hands you something useful back. So if we save this, actually, let's change this 2 to 1, just so that we know that it ran properly. So we switch back over to Isaac, and then we rerun our mod, and it changed back to true. We change it to a 2. Sorry about that. We changed it to a 2, and we save it. And we run it again, it comes back false. Brilliant. Whew. So that's a lot of work on what functions are and how they do right away. We're moving right along. But not every function has to return something. So if we take do something and remove the a equals from in front of it, it's now a void function. I know you want it to suck up active items, but that's not what it does. Void functions don't actually return anything. So we can get rid of this return and then do something else with it. So let's say a equals b. Now I know if you were actually familiar with coding, you'd look at this and you might not be certain of the result. You might have heard what I said at the beginning and be a little bit suspicious. But only a little bit, because I was talking about pass by reference, pass by value. That's not this. But scope, oh, this is a big thing about scope. So if you look at this, you start at the beginning, you set a equal to 1. Then you get down to do something and you pass it 2, which gets shoved into b. And then you set a equal to b. Now, when we get back out of here, is the value of a 1 or is it 2? Is this a inside this function the same a as this a out here? What do you think? I'm going to give you a little time to think. Okay, I think that's enough time. I'm going to save it. Switch back over to Isaac. Now we get to see. Does it come out as 1 or does it come out as 2? That's right, it comes out as 2. The a inside the function is the same a as the one outside of it, because this a was not defined in the function. It was defined out here. Now, if we went local a equals b and save it, now the final result is 1, because now the a in the function is in a different scope than the a outside the function. When you don't define something as local inside a function, it is global. It looks outside the function for its definition. Now, this doesn't seem particularly pertinent now, but there are situations where if you've got something commonly named, like player or room, you might have scope conflicts where you think you're using it locally inside the function, but you're actually using a global one, or you want to be using a global one and you're only using a local one. Oh, scope is a pain, but it helps you keep things organized and keep them from interacting in ways they shouldn't. So whenever possible, use local variables, because you know what they're going to do. we know that this A is never going to interact with any other A anywhere else in our program, except possibly one defined even further into this function. Because, like we saw with this local, it can go into functions that are in the same scope as it. So if we had something inside this function, like a for loop. So for example, for I equals 1 to 10, and then we had A equals I. For loops set up their own scope too. This I is local to this for loop. No matter how many other I's you have in the world, this I is local to this loop. And then it sets A to be equal to this I. Well, which A? Well, it's not a local A because we don't have a local A. It grabs this one. And if we didn't have this one defined locally, it would be this one. Oh, we forgot our do. So in theory, I haven't practiced this, so it might go horribly awry. If we run this, hey look, our final result is 10. Because we were in the loop, it went through each of the 10 and assigned it to A. So A is 10. Okay, so all of this should seem fairly straightforward to you. You might have gleaned a lot of this knowledge already. Now we're going to do something a little bit weird. So we're going to stop worrying about the scope of A, and we're going to start worrying about the nature of B. And you're like, Lyte, I don't care about B. I care about A. Well, what happens if you pass A into B? So what we're going to do is we're going to take A, set it to 1, then we're going to hand it off to do something. And then do something is going to set that variable equal to itself plus 1. So we're going to take A and make it bigger. Or are we? It's a curious little conundrum. Because you take A and you pass it in. And now this B is A. And then we add 1 to it. Right? Well, let's save it and run it. And once again, I'll ask you. Do you think A at the end is going to print out 1? Or is it going to print out 2? It's just going to print out 1. Because when we pass this A into the function, we're doing so I value. So we take the value of A and hand it to B. We're not handing A itself. We're handing the value of A. So we take the number 1, which is stored in A, and hand that off to B. So B becomes 2, and then it's thrown in the garbage. We don't need it. All we care about is A. So, I keep saying these things. They seem fairly straightforward. I mean, pass by value might seem a little weird to you, but it's probably what you would expect. You take this thing, you pass it in, it doesn't affect it on the outside, but you might have thought that passing in the player would let you change the player and it'll change the player. Well, player's not just a regular old variable. Player's actually a table. Tables might work differently than numeric things or string things. This is just a number. We can pass the number off and it'll be fine. So let's try it with a table. Because you can't take anything for granted. So we're going to have table where value equals A. So we've done this sort of thing before with the drip IDs, with all sorts of things. We've made tables that are indexed by things and they take values. So we're going to take A, we're going to put it in this table. Okay? And then we're going to send the table into our function. Our table is now B. And then we're going to take the index and we're going to make it larger. And then we're going to get A and set it back to table.value. So we got nothing back from do something. So we have table.value, we pass the table in, we increment the value part of this table, which is now B, and then we throw it away. just like we did before, and then we set a to table.value. Well, the question, once more, will it print 1 or will it print 2? That's right, it prints 2, not 1. I know, the way I asked the question, you had to be getting suspicious. If I brought it up, there had to be some trickery involved. Well, it turns out Lua treats tables and basic data types differently. So numbers and strings and floats, integers, those are treated differently than tables are. So when you pass just something that's a simple value into a function, it's passed by value. When you pass a table, it is passed by reference. So anything that you do to it on the inside sticks. You haven't passed the value of the table. You haven't made a copy of it. There is only one instance of this table, and it's going through this function. And anything you do to it, you do to it. So if you add 1 to value, 1 gets changed. The value gets changed by 1 in the table because there is only 1. However, it's just a variable with a value. You can pass that value along real cheap. You can make a copy of it, hand it off to B. Nobody will be the wiser. It doesn't affect performance, not really. And so you end up with different behaviors. Now this is really important because there are a lot of things that act one way in a certain situation and a different way in another. And you need to know whether or not what you got was a value or if what you got was a reference. The trouble that we had for a long time, not a long time, it was for like a day and a half. But with the evaluate cache, the player that was sent to evaluate cache was sent by value instead of by reference. So when you did player.damage equals player.damage plus 1, well, it updated the copy, which just got thrown in the garbage. But now that it's done by reference, oh, you've been passed a player, you modify damage, it modifies the player. It's pretty brilliant. And so you can see how passing by value or reference and the local versus global scope can affect the outcome of your programs. And how functions can help encapsulate what you're trying to do. So if you need to do the same thing over and over and over again, you can write a nice little function that'll do it for you. Now, whenever working with a function, you don't have to have just one argument. You can have all sorts of arguments. You just separate them by commas, and then here, you separate them by commas, and you give them more things. You know what else you separate by commas? Things in a table. So when written in a single line like this, it's pretty easy to keep track of which things should have commas and which don't. But sometimes it helps, reading-wise, to set up tables kind of like this. So it's easier to see which of the types of things are in the table. Then it's a little more difficult to see where the commas go. Same can be done for functions, but it's less advisable. You don't really need to see all of the different arguments that you pass in separated out like that. So there's one more thing that I want to show you, and it's the documentation, because at some point you're going to have to look at it. You're going to have to work through the documentation, even if you just need to see which arguments things take. So what I'm going to do is bring that on over onto the screen. And we'll talk through it a little bit, because a lot of these things are functions. See? Functions. And what this tells you comes in two parts. On the right-hand side, you've got the function and the things that you want to give it. So like for grid spawn, when you're making a thing in the room, you give it an integer, so a number, an integer, a vector, and then a boolean, which is true or false. So you give it 4 things. But on this left side, it tells you what it gives you back. It gives you back a grid entity, which more importantly is a reference. That's what this little ampersand tells you. It is a reference to a grid entity. So it will make a grid entity that you can then modify on the fly. You can keep this in a variable and then reference it later if you need to change its color. So you want to make a rainbow fire. You grid spawn a flame, store it in a variable, and then as time goes by, you change the color of that variable. Because it's a reference, you can do it. Whereas get frame count gives you an integer. Not a reference to an integer, mind you, just an integer. So if you throw that into a variable, it's not going to change out from under you, and if you change it, it doesn't affect the game. It doesn't affect the game in the slightest. You can try to set the frame count that you got, it's not going to do anything. Get player gives you entity player reference. So when you get player 0, it gives you a reference that affects the game. Whereas if you get the current challenge or get card ID by name, you can change the variable it gives you all you like, but it's by value. It doesn't do anything. It just changes your variable. Now, register mod doesn't have anything here, which is sketchy. They just didn't want to tell you the sort of thing that it gives you. Add callback might be void. I haven't tried setting something to mod : add callback. But anywhere in the documentation under functions, that's how it works. So if we wanted to look at the player, you've got a lot of void functions that add hearts, add eternal hearts. It doesn't return anything back. Boolean, true, false. So is it a black heart? You look at a particular heart. Is it black or not? Gives you true or false. If you try to change that variable, nothing happens. Whereas add blue spider, add a position, returns an entity, reference. So likely it gives you that blue spider. So if you want to do something fancy with that particular blue spider, you save it into a variable, do all the changes, good to go. And then you can go through all of these and see which things are references, which things are not. What does it give you back? A pill color when you get pill. It doesn't give you a pill type. You still don't know what it does, but you know what color it is. When you get down to the bottom, when you get to attributes, these are not functions. These are just variables. These you don't use a colon with. These are player dot tiers offset. Gives you a vector reference, but it's constant. Ugh. Constant means don't change it. You can't change it. If you try, it'll probably yell at you. All the rest of these, integer, float. Okay. But we can change these. Why? Because these are attributes. They're not returning something to you like a function would. They're just a variable. They're attached to a reference, so when you change these, it does change things. But given the way Lua works, a lot of these stats, you have to do it at a very particular time. So if there's anything else that you want to know about scope or functions, please let me know. I will try to cover it for you. But I think this has been more than enough to get you up to speed on how functions work, how the local versus global scope works, and passing by value versus passing by reference. So I will see you in the next episode of the Modding of Isaac with Lyte.